Bismillahirrahmanirrahim. Today's lecture is devoted to the understanding of thermal radiation and black body radiations. Thermal radiation is a part of the ways by which we can transfer heat from one place to another place. Before the thermal radiation, we had discussed two other ways. That was the conduction and convection process. Both conduction and convection processes were used to transfer heat from one place to another place. In case of conduction, the heat was transferred without the transfer of mass. The motion of electrons or the vibration of electron were responsible for that, and the heat was transferred without the transferring of mass, and for that purpose a special material called as a conductor were used. The other process was the convection, that were normally common in fluids, normally in liquid and gases, where the heat was transferred in such a way so that the mass, the quantity of matter was also transferred with it. When the mass is heated, it is transferred from one place, carrying the heat with itself. So that was the convection process. And today we discuss the radiation or the thermal radiation process. And one of the most common example of thermal radiation is the black body radiation. So this is the topics of the course of thermodynamics, and this is actually the title of today's lecture. So what we have understanding from this lecture is that we need to know the thermal radiation, and we need to know how the energy is transferred from one place to another place. What is the main thing that is responsible for it, especially the electromagnetic radiation, that is responsible for that, and the magnitude are the factors on which the thermal radiation depends. So later on we need to know the black body radiation as well. Black body are also a type of thermal radiation that are emitted and absorbed by a black body. So that is why is given a specific name that is called as a black body radiations. So first we need to know thermal radiations. So thermal radiation is really very interesting for us because it is quite useful, because the energy or the heat coming from the sun is also an example of thermal radiations. And for thermal radiation we don't need any medium, just like in case of convection and conduction process we need some medium, but unlike that, those processes, in case of thermal radiation or the radiation, the heat is transferred without any medium, or in other words you can say this is actually electromagnetic radiation that consists of electric field and magnetic field, and it don't need any medium for its moving from one place to another place. So if you want to measure high temperature range, that is about the gas temperature range, then it could be done with the help of thermal radiation. What is done in this way? We place your hand near a hot object and experience its heat without touching it. So this is something as a thermal radiation, because we even did not touch it, and the radiator and we place the hotness of that object nearby, or maybe it's some distance out of it. So this is the mechanism of thermal radiation, transferring the heat from one place to another place. Heat, just like coming from the sun, is also transmitted across this space due to the thermal radiation. If we consider the heat coming from the sun to the earth passes through 93 million miles empty space. So it means that we don't need any medium for the transferring of thermal radiation or radiation from one place to another place. So it is very interesting to us because the heat is transferred from sun to us with the help of this particular type of radiations. So initially these radiation were named as a radio waves because there was low understanding about it, and later on it was given as a electromagnetic radiation. And the substance may be stimulated to emit electromagnetic wave due to a number of, we can create electromagnetic waves from materials in a different ways, through a number of ways. So how we can create electromagnetic radiation from some material is, the first thing is that electromagnetic radiation are not actually a single radiation, but it is a spectrum of radiation having different wavelength and frequency, and depending on its frequency it has varieties of energy. In some cases we have high energetic radiation, and in some cases we have low energetic radiation, but it is quietly used in electromagnetic theory, and also in the especially in cell phone and things like that, and in transferring data from one place to another place. TV, radio waves and radar all comes in the electromagnetic spectrum. So how we can create electromagnetic radiation is not very different, because varying electric and magnetic field can create electromagnetic radiations. And some of the example to create specific amount of electromagnetic radiations are mentioned here. The first one is an electric conductor having high frequency alternating current. High frequency alternating current emits radiation, and these particular radiations are called as radio waves. We have electrons oscillating. Electrons that are oscillating in magnetron type tube emit radiation. If electron oscillate, because electron is actually a charged particle, so its oscillation creates some sort of electromagnetic radiation, which are called as microwaves. The created electromagnetic radiations are in the range of microwaves. Hot, solid or liquid, when we increase the temperature of some solid or liquid, so what happen, it emit radiation, and these radiation come across the infrared section of electromagnetic radiation. These are actually the thermal radiation, carrying the heat from one place to another place. And similarly, a gas experiencing an electric discharge emits some electromagnetic radiation, and it comes across the visible ultraviolet spectrum of the electromagnetic radiations. So similarly, when a substance is exposed to ultraviolet light from an external source, then it also emits a fluorescent light. This is also an electromagnetic radiation. So when a metal target is bombarded by high speed electron, then as a result of this bombardment, an electromagnetic radiation will be created, which is called as X-rays. And some of the radioactive materials, due to its instability, it continuously emits some sort of radiation. So that radiation, depending, in some cases beta radiation, but in some cases the radiation emitted are called as gamma rays. So this is actually the 7 different ways. We have more different ways of creating electromagnetic radiation, but this is just an example of different ways how we can create different electromagnetic waves among the spectrum by varying electric field or magnetic field or different phenomena, and this particular electromagnetic radiations are created. So the thermal radiation that are actually emitted, the today topic is only devoted toward the understanding of thermal radiation. We are not interested in the other electromagnetic spectrum because it is not relevant to this course. What we need to understand in this course is the thermal radiation, and that is actually especially in the infrared range which carry the heat from one place to another place. So this radiation emitted by solid or liquid by virtue of its temperature is actually the thermal radiations, and the thermal radiation dispersed by prism Our diffraction grating gives us continuous spectrum of visible light and invisible radiation, visible and invisible radiation. So similarly, at temperature below 500 degrees centigrade, the energy is in infrared radiation, while at higher temperatures, more visible light is emitted in case of thermal radiations. So increasing the temperature of a body will increase the greater total energy emission of the radiation. When we increase the temperature of a body, the emission will also increase, and that emission will range especially in infrared and visible range. But if we consider the total energy of this emission, that it will gradually increase with increasing the temperature of that particular body. So how to compensate the energy loss due to the radiation? As according to the law of conservation of energy, if a body is emitting radiation, there should be something to compensate it. I mean, there should be a source which try to keep the continuous emission of that radiation, or that there should be some other source. So this thing is very important for us to continue the long-standing emission of electromagnetic radiation. If there is no source behind the emission of some radiation, it will gradually decay and finally it will vanish. So in case of radiation emission, we have different examples. Just like if you consider, if the emitting body may be a source of energy, just like if you consider the sun, it is actually the source of energy. I mean, energy is created over there, and due to that its temperature is increased, and due to this increase in temperature, the heat is released in case of in the form of thermal radiations. In some cases, we have constant supply of electrical energy from the surrounding, and that leads to the creation of thermal radiations. In some cases, or some particular example, energy supplied by heat conduction processes. I mean, we must need to have a source which can create or which can compensate the radiation emission process. So in some cases, energy is supplied by performance of work. So in the absence of sources, what happen? The body may receive energy by absorption of radiation. I mean, in some cases, if there is no absence of source, so what happen? It may be possible that the body may receive energy by absorption of radiation, or body immersed in the radiation, or the total internal energy of the system will remain constant when the rate of emission and absorption become equal. If there is continuous source supporting the emission process, and the emission and absorptions are equal to each other, so in that case the internal energy of the system will remain constant. And what happen? The radiant energy absorption should be equal to the radiant energy emission. So the power leaving the body due to thermal radiation depends on some factors. In this slide, we want to elaborate that on how many factors the power leaving the substance or the material depends. The first thing is the temperature of that particular body. The second thing is the surface area of that particular body. The third thing is the nature of the surface. I mean, what type of nature of the surface we have. And so these are the three main factors on which the power leaving the body due to the thermal radiation depends. So in case of isotropic radiation, the thermal radiation incident upon a body is a body equally from all directions. So we have absorptivity, that is actually a special term used here, that is actually a fraction of total incident power that is absorbed, and emissivity is actually the fraction of the power provided to the real body that is emitted through a material surface as a thermal radiations. And here we have radiant excitance. Radiant excitance R should be equal to the total radiant power emitted per unit area, and total emissivity should be equal to the fraction of the total radiant power that is emitted as a thermal radiations. So an ideal substance capable of absorbing all type of radiations or emitting all energy provided to it in the form of thermal radiation is called as a black body. So in this slide we are mainly concentrating on the black body radiation, which is also a part of a type of thermal radiation, but due to the nature of the body we call it as a black body radiation. So this is actually in the thermal radiation, and this is some body which is emitting and absorbing all energy provided to it in the form of thermal radiation. And black body we can represent it with the help of EWB. So the emissivity of the black body should be equal to 1. So it means the energy emitted should be equal to the energy absorbed, and it can absorb all type of radiation and even emit all sort of radiations. So what are actually the condition for the perfect black body? The condition for the perfect black body is that there should be a cavity, and the cavity should be enclosed by high temperature opaque walls. So what happened, there should be the interior should be high temperature, I mean it should be a perfect black body. So thermal radiation pass through a hole and enter the body. So this is the shape of the body. I mean the thermal radiations are entering the black body with the help of a hole, and at that place it is absorbed. So the irradiance power is actually the radiant power per unit area incident upon the surface of the black body. So the radiant power absorbed per unit area is equal to E. This is actually the emissivity of black body, that is equal to 1 EWB into H, and it is equal to H. Our radiant power emitted per unit area is equal to radiant power emitted RWB. This is for especially black body. The radiant power emitted per unit area is equal to RWB. So for constant temperature of black body, absorbed radiant power per unit area should be equal to the radiant power per unit area leaving. If we consider the black body in case of equilibrium, so what is the main condition for it? The radiant power emitted by the body should be equal to the radiant power absorbed by the same body. So at that time it will be at constant level, or it will be at equilibrium level. So this is actually the condition for H, and H should be equal to RWB. And the irradiance within a cavity whose walls are at temperature T is equal to the radiant excitant of a black body at the same temperature. This is the condition that the radiant excitant of a black body at the same temperature should be equal to the irradiance within a cavity whose walls are temperature T. That is why the radiation enclosed with a black body is called as a black body radiation. That is, the specific name is given to it, and that is why it is called as a black body radiation. So H, here the H is independent of the material of which the interior walls are composed. In case of the black body, perfect black body, the radiations of the body is independent of the nature of the material, but it only depends upon the temperature. So this is very interesting, that the radiation in this case only depends upon the temperature of that material. So this is something about the black body radiation. So the most important thing for the black body radiation is that the radiation emitted by this particular type of body, this particular body is only dependent on the temperature of material, irrespective of the nature of material. Actually, in general, we says that the black body, the radiations leaving a body depends upon the temperature of material, it depends upon the surface area, it depends upon the nature of the surface. This is for the general cases. If we have generally temperature of a part, so it depends upon the temperature, surface area, and nature of the surface. But in very specific case, in case of black body, it only depends upon the temperature of a body. So this is really very interesting for us, that only the temperature of a body. It depends. So increasing or decreasing the temperature of a body, we can absorb or emit the radiations, but in this case is not depending on the other factor, just like the surface area or the nature of that material. So this is something about the black body radiation and thermal radiation. I hope in next class we will develop some quantitative relationship using Stephen Boltzmann law and Kirchhoff laws for the understanding of black body radiation and thermal radiation. Thank you very much.